Okay, I'm sharing my screen. Is screen visible?
Yes, ma'am.
Okay. So today is fourth week. You people are listening that professor's lecture, right?
Yes, ma'am.
So how he used to give lecture, like how you people like it's lesson ninth, eighth, ninth, tenth. So in 1 week, he used to take four lecture or three lectures. How many lecture he is taking in 1 week?
Two or three, ma'am.
Okay. So you are listening that lectures properly and simultaneously you are listening, like week by week you are listening.
Yes, ma'am.
Okay. So today we will discuss this fourth assignment. So for that, I think this is basics of X-rays only. So might you know answers you know. So we will discuss this fourth assignment. So first, I'm starting with the question number first. If you people know, then you can unmute your mic and you can tell the answer. So in the first question, I can see that you have to submit that assignment by 24th of August, right? So what is the day on 24th? Wednesday. Okay, so we will discuss. So the question first is to obtain a strong line from a copper target, the filter material to be used is. So which metal we can use as a node in X-ray tube? Can someone tell?
Nickel, ma'am.
Okay, for copper you are saying like nickel filter we should use, right? So the correct
Yes,
option
ma'am.
is fourth, nickel. So do you know for cobalt?
Iron, ma'am.
Iron, right. And for iron?
Manganese, ma'am.
Okay, yeah, right. So the second question is to avoid formation of fluorescent radiation, the wavelength of incident radiation should be dash than the absorption edge wavelength of the material being investigated. Higher, it should be higher, lower, or same wavelength. To avoid formation of fluorescent radiation, the wavelength of incident X radiation should be dash than the K absorption edge wavelength of the material being investigated. You are not audible.
Don't know, ma'am.
Okay. In the X-ray, if we want to avoid the fluorescent radiation, then we should use the higher wavelength of the incident X-rays than that of the K absorption edge wavelength. So for this question, they are asking about the wavelength of incident X radiation, so it should be higher to avoid the fluorescent radiations. And the third question is the linear absorption coefficient of a material depend on its electrical conductivity, ionization potential, physical state, or magnetic domains. So, according to this question, the linear absorption coefficient of a material depends on its electrical conductivity, ionization potential, physical state, or magnetic domains. So, the linear absorption coefficient of a material depends upon its physical state, like either it is solid, liquid, or gas. The absorption coefficient will depend upon its state, like what is the state of matter, either it is solid, liquid, or gas. So, this absorption coefficient will always depend upon the physical state.
Hello.
So, the fourth question is the intensity of the white radiation can be increased by increasing the dash of the target material. So this answer you should know. So the intensity of the white radiation can be increased by increasing the dash of the target material.
Temperature.
What?
Temperature.
Can you say little bit loud?
Temperature. Temperature. Temperature.
Temperature. So how intensity is related to temperature?
Intensity will means the target material will absorb more cation. Am I audible, madam?
Actually, you are like very slow voice. I can hear. I can't hear
Maybe
it.
a network. Maybe I'm not also
Yeah,
network.
now you are audible. Can you say again how intensity is related to temperature?
With the fourth power of temperature, intensity is related.
So
Intensity
if
will
you
increase.
are giving high temperature, then what will happen?
The intensity will increase.
How? How intensity is related to temperature?
The intensity is related to the fourth power of the temperature. I think that's the black body radiation formula.
Intensity is related to.
T to the power 4, proportional to T to the power 4.
So is this relation valid in X-ray? Yeah, intensity is directly proportional to T raised per 4.
I have no idea if it is valid on X-ray also.
So, according to me, the intensity is like how the intensity will increase when more number of electrons will strike. Like, right? When we heat the filament, like when we heat the anode, the more electrons will come out of that filament and it will strike more to the target material. So, more number of electrons will hit the target, right? So, with increase in the number of electrons which is going to hit the target, it will increase the intensity of light. So now, can you tell out of these four options how intense, like what will be the correct?
Atomic number, ma'am.
Yeah. So by increase in the atomic number, the number of electrons will also increase. So if the number of electrons are increasing, so more number of electron the material can release, and the no more number of electrons will hit the target, and it will lead to increase in the intensity of radiation. Understood?
Yes, ma'am. Yes.
Okay. Okay. Hmm. So the next question is ionization devices measure the intensity of X-rays by the amount of ionization they produce in a dash. So the options are crystal, gas, fluorescent screen, and coherent beam. So they are asking like ionization devices. So how ionization devices measure the intensity of X-ray beams by the amount of ionization they produce in a dash. So if a sample will ionize, so how means in which medium it will ionize? It is like, is it in a crystal foam, gas, fluorescent screen, or coherent beam? So in crystal it will not ionize, right?
Yes, ma'am.
So what will be the right answer?
So the gas.
Gas, yes. So ionization devices, whichever the ionization devices we are using, so they measure the intensity of X-rays. X-rays are produced in the cathode ray tube, and there are some ionization devices which will like determine the amount of ionization, and this ionization will happen in the gas. So the ionization devices measure the intensity of X-ray beam by amount of ionization they produce in a gas. So the sixth question is, most of the energy of the striking electron against the target in an X-ray machine is converted into dash. So
X-rays.
most of the energy of the striking electrons against the target in an X-ray machine is converted into X-ray,
Ma'am,
right?
ma'am, it is in the. Ma'am, are they considering the target in the system, like in the device, X-ray machine or device, or the target they are analyzing?
What? Again, you tell?
Ma'am, they are mentioning the word target in the question. It is the target that the X-ray machine will analyze, or in the inside the machine the target is used. If it is the target that is used in the machine, then it will be X-rays, or if it's analyzed target, I think it will be something else.
So most of the energy of striking electron against the target in an X-ray machine is, so it is like in question they are saying like in an X-ray machine. So they are asking about the target inside the tube, right? In an X-ray machine. So inside they are asking about
Okay, ma'am.
so according to you, it should be X-ray, right?
Yes, ma'am.
So, like ideally, whenever we are reading, so ideally it should be X-ray, but like all of the electrons will not be able to produce the X-rays, right? For producing some X-rays, they should hit the target with some threshold frequency, then only it will provide X-rays. But all of the electrons will not be having that much energy. So most of the electrons will end up with converted into heat.
Okay.
So most of the energy, if there are like millions of electrons, so million of electron will not, like all of the electron will not produce X-rays. Some of the electrons will be having that much energy so that they will be capable to produce X-rays. But all of the electrons, like only in ideal condition, if we are giving four electrons and four electrons will produce X-rays, right? So this is an ideal condition. But ideally the condition, like theoretically, we will not get like experimentally we are not getting these kind of situations. So it is like sometime three electron will give, one electron will be wasted, like its energy will be converted into heat. So it is like that most of the energy of the striking electron against the target in an X-ray machine is converted into heat.
So the answer will be X-ray or heat. If,
Heat. So most of the energy of the striking electron against the target in an X-ray machine is converted into heat. If you people have attending the lectures, then can someone tell like what is the like principle, like how X-rays are producing inside a cathode ray tube?
Remember heating of a filament?
Like, can you tell properly like what will be the apparatus? It is like
Where
heating and filament only. This is right only, but some more elaborate. Can you explain?
Now, I don't remember exactly, but it's in an evacuated chamber. Then the filament is heated, then it hits a target material. From the target material, X-rays are produced. But then also in the other side, there will be some kind of a cooling systems, and that's it. I don't remember properly.
No, no, but you are saying right only. So in the cathode ray tube, when the filament which is like heated, which will give the electron, this is like this is like an cathode, and on the other side, the material which will like receive that electron, that will be anode, and after hitting some rays will be produced, and that rays will be filtered. In first question they are asking about the filter, now only that filter they are asking, like after hitting the anode the rays will be filtered, and which filter for different metals different filters we will use. So in a tube, so basically in this we are using a filament as a cathode, like from cathode only electrons are releasing, so we can say this is cathode ray tube also, and since x-rays are produced we can say this as x-ray tube also. So what happens is in a tube one cathode is there and one anode is there, so cathode will give the electron and an anode will accept that electron. So cathode will be heated, and when it will be heated, it will go to higher energy, and whenever it is going to higher energy, then it will release the electron, and the energy of that electrons will be very high. So that high energy electron will move towards the anode and it will hit. So it will result in the production of X-rays, which then filtered through one anode, and the detector will detect that X-rays.
Okay, ma'am.
Hmm. So ideally, like whatever I was saying in this question, ideally it is like whenever cathode is heated, so the number of electron which are released from the cathode, all the electrons should, when strike to the anode, all of the electrons should produce X-rays. But it will not happen like that, because if you see, like in a tube, if this is cathode and this is anode, collisions will happen, and it is not necessary that electron always go and hit the anode only, because in a tube that other, it can hit the wall also, so that electron will end up with that of heat only. It will not produce the x-rays. The electrons will produce x-rays when it will hit the anode, but many possibilities are there. So all the electrons will not produce x-rays, but some of the electrons will end up with that of the production of heat.
Okay, ma'am.
So, in the intensity of white radiation is zero up to a certain wavelength. So, this statement is true. But in eighth and ninth question, they have not mentioned which line. So, this question is incomplete. The intensity of the dash line is more than the intensity of dash line, and the wavelength of the dash line is larger than that of the dash line. This is incomplete questions.
I mean, our side is not incomplete.
Oh, it is in your side. It is what the question is.
The intensity of copper K alpha line is more than the intensity of the copper beta line. True or false?
So one is intensity of K alpha line.
Yeah.
So the question is the intensity of K alpha line is
Of
more than that
copper.
of the K beta line.
Of copper.
The intensity of the K alpha line is more than the intensity of the K beta line of copper.
Yeah, it's copper. The question is actually the intensity of the copper K alpha line is more than the intensity of the copper K beta line.
Ha ha ha. Okay, okay, understood. Copper K beta. Yeah, so the intensity of, so is this statement correct? The intensity of the copper K alpha line is more than the intensity of copper K beta line.
Ma'am, no, false.
This statement is false.
I'm not sure about it actually.
Okay, so this statement is true only because if you are listening that lecture, maybe he has explained one graph. Whenever one like X-ray is produced and it will hit the director, this kind of graph will form. Like one peak like that and one is small peak. So K alpha is bigger peak and K beta is smaller peak. So K alpha intensity is more than that of the K beta line. If you will see, I will show. I don't have any board. Right, this type of graph, if you are remembering,
Yes, yes.
yes, na? So this type of graph he might be explained.
Yes.
So it is sure that he explained only. So on y-axis, this is intensity and this is wavelength. So you people can see. So K alpha is the intensity of K alpha is greater than that of K beta line. So now, what is the question? The intensity of K alpha is here. First is K alpha or K beta?
First is copper K alpha, then the second is K beta.
Okay, so the intensity of the copper K alpha line is more than the intensity of the copper K beta line. So this is true or false?
It's true from the graph like that.
So this is, yeah, this is true. And what about question second?
The ninth question is also the wavelength of copper K beta line is larger than that of the copper K alpha line.
So now here is K beta first, right?
Yes, K beta first.
So the wavelength of copper K beta is larger than wavelength of copper K alpha. So this is this right? You can see this graph.
Okay. Then now the wavelength of copper K alpha is first.
It is towards zero point 0.8 and for K beta it is zero point 0.6.
It's 0.6.
So this statement is false.
Yes.
So the mass absorption coefficient of a material is the reciprocal of its linear absorption coefficient. I don't remember the relation between these two, but I think they both are not related reciprocal. Like it is not in reciprocal relation. So the mass absorption coefficient of a material is the reciprocal of its linear absorption coefficient. So someone remember the relation between these two?
Um,
think it's false, ma'am.
It is directly proportional.
Yes, ma'am. Because the linear absorption coefficient of a material is nu, and mass absorption coefficient of a material is nu by rho. So there is no inverse proportionality between them.
So it is like false, right? It is false statement.
Yes, ma'am.
Okay. So X-rays are produced whenever high-speed electrons collide with the metal target. Is this true or false? Now only I explained, right? How the X-rays are produced, now only I told.
Ma'am, it is heating a filament, but is it necessary to be of high speed? By high speed, what they mean?
High speed, if they are having high energy, if they are going to hit the target by high speed, means if they are having high speed like high energy, then only it will go. If an electron is going like slowly, and if electron will go by high speed and it will hit the target.
But it is
so
necessary. True.
so means like for getting high energy electron, like our requirement is like electron should be having high energy and it will go with like high speed and hit the target.
Yes, ma'am.
So and also it is not necessary like every high, like every electron which is in higher speed will hit the target only. The electron can hit inside, like inside a X-ray tube, gas molecules are also there. It is not necessary that always it will hit the target only. It can collide with gas molecules and lose its energy, and it can like strike with the wall and lose its energy in the form of heat. So it is like for our requirement is that electron should be with high energy and it should go with high speed and it will hit the target. So these three conditions, but these conditions will always not satisfy. So but for getting X-rays production, the electron should be in high energy, it should go with high speed to hit the anode target. So now
Okay.
according to question 11, they are asking like X-rays are produced whenever high speed electrons collide with a metal target.
Okay, ma'am.
So is it true or false?
Is it true? It is true.
Yeah. Okay. So according to 12th question, these question you in a this is like you people can do this question, but we will discuss. In a filament X-ray tube, electron are producing by heating a filament. How the electrons are produced in a X-ray tube?
Putting the cathode using.
So how the if cathode is there, if a metal is there, so it will produce electron. Like if we are not giving any energy, it will produce electrons.
No.
So what they are asking, electrons are produced by hitting a filament. This is true or false?
Yes, it's true.
Yeah, so this is true only. So if any cathode is there, like if any metal source is there as a cathode, so we have to heat that filament to get the electrons. So are X-rays harmful for body?
Yes.
X-rays are harmful for the body, right?
Mm.
So what are the more harmful rays for human body? Electromagnetic spectrum you read, right? Electromagnetic spectrum.
Like,
In lower classes only you read, right? Electromagnetic spectrum. Like
I
the
guess ultraviolet. Ultraviolet, cosmic ray, cosmic waves, and all those.
ultraviolet radiations are more harmful than X-rays, or X-rays are more harmful? So you remember, and someone remember electromagnetic spectrum. What are the sequence of radiations? How many radiations we are aware of? How many radiations are there in electromagnetic spectrum? Seven type of radiations, right? First is radio waves, microwaves. You did not listen about electromagnetic spectrum.
No, we have.
So these are the radiations. First is radio waves, microwaves. So how much? One, 2, 3, 4, 5, 6, 7. This visible?
Yes, ma'am.
Yeah, so these are the like there is one spectrum, there is one table for electromagnetic radiations. So in electromagnetic radiations and basically also in chemistry we are always reading about seven type of radiations. So the first is radio waves, second is microwaves, infrared radiations, visible rays, UV radiation, X-rays and gamma rays. So total are the seven radiation we come across with in like whole life. So these are the seven rays. Gamma rays are only the cosmic rays. These are very harmful. So whenever we are going, if we are consider, if whenever we are going from radio waves to gamma rays, there is always a increase in energy. So whenever there is an increase in energy, there is high penetration. Like whenever high penetration is there, like if where in human body we are using like whenever some fracture is there, what we will do in that case, what doctor will do if some fracture is there, then
Take X-rays.
then he will always prescribe to see like you can go for x-ray like to see the fracture how much it is, like it is mild or like high fracture. So for that he will do x-ray, he will not tell you like uv infrared, he will always go for x-ray and he will not tell for gamma rays because gamma rays are very harmful rays. X-rays are like these are also harmful for human body because these are high in energy and it has high penetration power. So due to high penetration only we will be able to see the parts inside the body, and these are the radiation which are like very low energy, and these radiation we are using in NMR only. So these radiation we are using for studying the rotational spectroscopy. This is for vibrational spectroscopy, UV visible for electronic spectroscopy. These are like different radiation which we are using in different spectroscopic techniques. So here I want to tell here is whenever we are going from radio waves to gamma rays, there is always an increase in energy. Okay, so whenever there is an increase in energy, there is high penetration, and that rays are more harmful for human body. So now you people can tell like UV are more harmful or X-rays are more harmful.
X-rays are
Yeah, so among these two, gamma or X-rays,
but
among gamma and X-rays, which are more harmful?
gamma.
Gamma rays,
Yeah,
ma'am.
so UV, X-rays and gamma rays, these all three radiation, UV we are like why we are putting sunscreen and all, why there is a like ozone layer have big hole because we are getting UV light from sun. So UV is also harmful, but more than UV, X-rays are harmful and gamma rays are very harmful for human body. So according to this question, so they are asking X-rays are not harmful for the human body. So is this statement true or false?
False.
False. Okay, so the question 14th we will do, 15th is numerical, so you people will do. So 14th we will discuss the operation of a gas tube depends on creating perfect vacuum inside the X-ray tube.
True, ma'am. True.
So this statement is true, na? Inside the X-ray tube there is evacuation we will do.
Hmm.
This is false, I think. The operation of a gas tube depends on creating perfect vacuum inside the X-ray tube. I think some gaseous atmosphere is there inside the X-ray tube. First, we will evacuate to remove all the gases, like multiple gases will be there inside the X-ray tube. But there is, I think, some noble atmosphere, like inert atmosphere, is there inside the X-ray tube. Means some gaseous atmosphere will be there in X-ray tube. So I think this statement is false only. I'm not sure. I will see this and then I will let you know. Like either it is true or false. But according to me, it should be creating perfect vacuum inside the X-ray tube. Okay, I will discuss it later. I will just confirm first. So this is numerical question, so you people can do. A nickel filter is used to produce. So for what a nickel filter is used for?
Density ratio of copper K alpha to copper K beta
Yeah, yeah.
of 100 by 1 in the filtered beam.
Hmm.
Calculate the thickness of the filter in microns
Microns.
given that mu by rho of nickel for copper K alpha radiation is 49.3
Yeah.
centimeter square
Per
per gram, and for copper K beta radiation it is 286 centimeter square per gram.
and density of
Then
nickel is given, right?
yeah.
So you people can try this, okay?
Okay, sure.
So this I will means I am not sure, but I think this can be true also because inside vacuum will be there. I will see this question, okay? Then I will let you know. So okay, so for today I think it is done this assignment, and till now there are 4 weeks they have uploaded, right?
And
Hmm. So you have to submit by Wednesday.
yes, ma'am.
Okay. Okay, so we
Okay.
can close, right?
Yes, sure, ma'am.
Okay. Thank you.
Thank you.
Okay, bye bye.
Thank you.